Today we are going to do the first session of JEE sequences and series. Well, as in all the other videos of the JEE capsule, we will be discussing topic wise. So the first topic is a very important topic that is known as AM-GM-HM inequality. First of all, what is the topic? If you have a set of positive real numbers such as let's say you have a set of positive real numbers a1, a2, a3 up to an. So the arithmetic mean is given by a1 plus a2 plus a3 up to an by n. The geometric mean is equal to the product of a1, a2, a3 up to an raised to the power 1 by n. And the harmonic mean is n divided by the sum of the reciprocals of a1, a2 up to an. So these are respectively called arithmetic mean, geometric mean, harmonic mean. Please remember that a1, a2, a3 up to an, they are positive real numbers. Now what is the AM-GM-HM inequality? The inequality is that for a set of numbers, for a set of positive real numbers, the arithmetic mean will be greater than equal to the geometric mean, and the geometric mean will be greater than equal to the harmonic mean. In any of these two inequalities, the equality will hold if all the numbers are equal. So in any of these inequalities, the equality will hold if a1, a2, a3 up to an, all the numbers are equal. So this is AM-GM-HM inequality. Let's have a look at some applications of AM-GM-HM inequality. For example, suppose we have to prove that suppose we have to prove that 1 raised to the power 1 into 2 raised to the power 2 into 3 raised to the power 3 up to n raised to the power n is less than equal to 2n plus 1 by 3 raised to the power n into n plus 1 by 2. Suppose we have to prove this inequality. So you begin with AM-GM. So we will write one series like this: 1 plus 2 plus 2 plus 3 plus 3 and so on. So you can see that up to n terms. You can see that if this is up to n terms, then the total number of terms is n into n plus 1 by 2. So this is the arithmetic mean. This is greater than equal to the geometric mean. Now the series in the numerator is the sum of the squares of the first 10 natural numbers. So ultimately, we are getting this type of inequality. Now this one, after simplification, it will give the final answer which we are supposed to prove. So the next step after this will be 1 into 2 square into 3 cube up to n to the power n is less than equal to 2n plus 1 by 3 to the power n into n plus 1 by 2. So this is an example of how to do a question using AM-GM inequality. Now let's try out a question where we have to involve harmonic mean also. Say for example, you have to prove that if ABC are positive real, if ABC are positive real, you have to prove that A by B plus C plus B by C plus A plus C by A plus B is greater than equal to 3 by 2. So how to prove it? If you add 3 to both sides, this is what you have to prove. So we have to prove this particular inequality. Now let us do one thing. Let us take arithmetic mean of these three numbers, B plus C, C plus A and A plus B. Is greater than equal to harmonic mean. Harmonic mean is 3 divided by 1 by B plus C, 1 by C plus A, 1 by A plus B. So we will get the desired result, the result which we are supposed to get. We were supposed to get this and we have got the result. So this is an example of arithmetic mean greater than equal to harmonic mean. So we have seen two examples, AM greater than GM, AM greater than HM. So let's have a look at another application. Prove that if A is not equal to B, prove that if A is not equal to B and A, B, X, Y are positive rational, such that X plus Y equal to 1, okay, so this is one application. There is a question, prove that if A is not equal to B and A, B, X, Y are positive rational such that X plus Y is 1, you have to prove that A to the power X into B to the power Y is less than AX plus BY. Now this is one application of AMGM. So what we have to do is we have to proceed like this. So you have to proceed like this. Suppose you write A X times and B Y times and divide this by X plus Y, so you will get arithmetic mean. And on the right hand side, this is has to be greater than the geometric mean. Now when you say A X times, so that's AX and BY times it's B times BY by X plus 1. So this is what we will get. Now if you just put X plus Y equal to 1, then you will get the desired answer. So this is another application of arithmetic mean greater than geometric mean. Suppose we have a question like this, prove that if A plus 2B plus 3C equal to 1 and ABC are positive rational, You have to find the greatest value of a cube b square c. This is the question. Prove that if a plus 2b plus 3c is 1 and a, b, c are positive real, what is the greatest value of? So you have to find the greatest value of a cube b square c. Now to do this kind of question, you will have to proceed like this. Instead of a, you write a by 3 plus a by 3 plus a by 3. Instead of 2b, you write b plus b, and instead of 3c, well, you just write 3c as 3c. So the arithmetic mean for this collection will be by 6. And we know that this is greater than equal to the geometric mean. So the geometric mean calculation will be like this. So this will be the geometric mean calculation. So a plus 2b plus 3c by 6. This will be 6th root. So it's coming 6th root a cube b square c divided by 9. So if you put a plus 2b plus 3c as 1, then a cube b square c is coming less than 9, less than equal to 9 by 6 to the power 6. So this is the answer. The question was what is the greatest value? This is the answer. So this is another example of the application of AMGM HM inequality. In certain cases, the inequality may require a trigonometric substitution. For example, if a and b are positive real and a plus b is 1, you have to show that a plus 1 by a whole square plus b plus 1 by b whole square is greater than equal to 12.5. This is the question. Since a plus b is 1 and a and b is positive real, we can make a substitution. We can take a equal to cos square theta and b is equal to sin square theta. So this will give us cos square theta plus 1 by cos square theta whole square plus sin square theta plus 1 by sin square theta whole square. On the left hand side, this is what you will get. So after expansion, we will get cos to the power 4 theta plus sin to the power 4 theta plus sec to the power 4 theta plus cosec to the power 4 theta plus 4. Now cos to the power 4 theta plus sin to the power 4 theta can be written as 1 minus 2 sin square theta cos theta and these two can be written like this: 1 plus tan square theta whole square plus 1 plus cot square theta whole square. So this is giving 1 minus half sin square 2 theta, and this after simplification is giving, so we have a 6, 1 plus 1 plus 4 plus 2 into tan square theta plus cot square theta plus tan to the power 4 theta plus cot to the power 4 theta. Now we know that the maximum value of sin square 2 theta is 1, and using AMJM inequality, the minimum value of tan square plus cot square is 2 and tan 4 plus cot 4 is also 2. Incidentally, the minimum value of tan square plus cot square, the minimum value of tan 4 plus cot 4 and the maximum value of sin square 2 theta all happen when theta is 45 degree. So we can apply maximum of this and minimum of this simultaneously, and after simplification we will get 12.5, which is the required answer. So this is the topic number 1 of this chapter, and this is how we apply AMGM HM inequality. Now we come to topic number 2. Topic number 2, it is basically finding the sum of a series such as 1 into 2 plus 2 into 3 plus 3 into 4, or 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5. So finding the sum of these type of series, that is what topic 2 is all about. So let us begin by taking a general term. Let's call it Tk. So let's say Tk begins with the natural number k, and to find Tk we are writing k into k plus 1 into k plus 2 up to k plus r minus 1. So naturally, if this is Tk, then Tk plus 1 will be equal to this. By combining these two, we can easily see that k plus r into Tk is the same as k into Tk plus 1. So we can rewrite this equation in another form. K minus 1 into Tk minus k into Tk plus 1 is equal to minus of r plus 1 into Tk. Now this particular equation, if you keep applying the values of k starting from 1, then this is what you will get: 0 into T1 minus T2 equal to minus r plus 1 into T1 then 1 into T2 minus 2 into T3 equal to minus R plus 1 into T2, and so on. So the next term will be 2 into T3 minus 3 into T4 is minus R plus 1 into T3. So if you add all these equations, suppose you add all these equations, then the result will be and mind you, the last possible value of k is n minus r, so the result will be this. Now suppose on both sides you add Tn minus r, so n minus r by r plus 1 into T n minus r plus 1. So if we add Tn minus r plus 1 on both sides, so this is what we will get. So n plus 1 by r plus 1 into Tn minus r plus 1. So Tn minus r plus 1 will be equal to the product of these numbers. So now you will see that we are basically getting a factorial representation n plus 1 factorial by r plus 1 into n minus r factorial. So ultimately the series summation is this. So this is a formula, and from now onwards we will directly use this formula to do the sums. Now let's say we want to find the sum of this series. So if you apply this formula, it will be n plus 1 factorial by 2 plus 1 into n minus 2 factorial. So the answer will be n plus 1 into n minus 1 by 3. Suppose we want to find the sum of a series like this. So n plus 1 factorial by 3 plus 1 into n minus 3 factorial so this will be the answer. So this is the topic, how to find a series of the product of successive natural numbers. So this completes topic 2 and it also brings us to an end of this session of JEE Revision Sequence Series.